Hey everyone, welcome to SingularityComputers Client Build 9, Part 5. This is the final part of the build log, and in this video I'm going to complete the system and then move on to the test results. The system is almost complete. I just need to finish the custom wiring and install the lighting. I'm going to start with something that a number of people have commented on the last couple of videos. I've used noise blocker E-loop fans in this build. They're the B12-2. I've used them in a push configuration on the front radiator and in a pull configuration on the top radiator. Now, a lot of people are saying that these fans have problems in a pull configuration. And what people are saying is that these fans are loud in pull. Now, I use these fans in a pull configuration in Client Build 8, Cytotoxic. I'll put a link on the screen to the build log. And I certainly did have problems with these fans. They were loud in pull. I found that the reason they were loud was because the fan blades were actually touching the radiator that they were mounted to. And not just slightly, they were touching it so badly that the fans could barely operate and the noise was terrible. So I had to swap the fans in that build. Now, I never write off a component based on what other people say. I like to do the testing for myself, and I will always test the component thoroughly before I make any confirmations. So that's why I decided to go ahead and install these fans in a pull configuration in this build, thinking that a different configuration may yield different results. But I knew that these fans definitely could be a problem, so I'm now testing them with an external power supply. And when I first switched them on, they weren't a problem, but I knew that the fan blades were going to be close to the radiator, so I shook the build side to side slightly, and sure enough, the fans touched the radiator. And, again, not just slightly, the noise was terrible, almost bringing the fans to a stop. So these fans cannot be used in a pull configuration. And if you take a look at the design of the fans, you'll see why. The blades are so close to the outside of the frame, they're nearly level with it, so it's impossible for the fan blades not to touch in a pull configuration. So I'm going to change the fans to Noise Blocker Black Silent Pro PL2s. Initially I was going to change all 4 of the fans, but I've now decided only to change the top 2 fans. Because having 2 white fans and 2 black fans is going to fit the color scheme. The specifications of Noise Blocker Black Silent Pro PL2s are also very similar to Noise Blocker E-loop B12-2s. And if you take a look at the top panel now that I've installed the PL2s, the entire top panel is black. Part of it is transparent and you can only just see the black fans through it. But if you take a look at the front panel, all of it is transparent, and through it you can see the white fans, and you can also see the white components inside of the build, the water cooling loop, and you will be able to see the cables once they're installed, and the white lighting. So I think it fits perfectly. Now, some of you may be thinking, why didn't I just swap the noise blocker E-loops on the top radiator to a push configuration? That's not really possible at this point because of the way I've done the mods. For example, I've cut circles in the top panel, and if I had have had the radiator showing on the top panel, I wouldn't have cut circles, I would have shaped it to fit the radiator, and I just didn't want that for the sake of aesthetics. I wanted fans showing on both the front panel and top panel. There's also a number of other reasons. Now, I didn't actually have to drain the entire loop and remove the top radiator to swap the fans. I was able to slide the old fans out from the side and slide the new fans in. So instead of taking a couple of hours, it only took a few minutes. I'm now going to complete the custom wiring. Now, previously I've promised to dedicate some videos to custom wiring, but currently I have too many client builds to do. I'm far too busy. All I have time for is build logs, so I'm going to have to delay the custom wiring videos. But in the meantime, I'm going to continue to include detail on custom wiring in my build logs. So far I've completed the 24-pin, 8-pin EPS and PCIe. So there is still a lot of work to be done, and I have most of my tools and materials laid out here ready to go, and also the cables I'm going to be modifying. Now, I make most of my cables up from scratch. I'll only modify existing cables that are very close to what I want. And you might be thinking that it's quicker and easier to modify existing cables, but I find it's the other way around. It's quicker and easier most of the time to build cables from scratch, and you can get better quality. So I have some SATA data cables here ready to be sleeved. I'm not yet sure what I'm going to be using for the lighting, but I have a couple of Bitphoenix Alchemy white 30cm LED strips and a couple of XSPC white 3mm LEDs. Now this is the wiring for one of the Vandal switches, but I'll end up making up all of this from scratch. I'm using a Mod My Toys splitter PCB in this build, and I use these in just about all of my builds. They're incredibly useful, and this is the way to really clean up your wiring. They have a massive range, so the possibilities are endless. The quality is also very good. So what I'm using in this build is a Molex to 5 3-pin splitter PCB. So I'm going to be able to run all of the fans off this PCB, and I'll also have a spare 3-pin fan header, which I'm actually going to use for the lighting. I'm now going to briefly take you through how to do heat-shrinkless sleeving. So if you're doing custom wiring and you're building the cable from scratch, you need to cut the wires, strip the ends, crimp the pins on, and then prepare your sleeving. Now all of that I just mentioned is a big process. It takes the correct tools. You need to be incredibly meticulous. And what I suggest is, if you're a beginner with custom wiring, you just need to practice. Practice crimping the pins on over and over again until you get it right. And do this with every aspect of custom wiring. Now I am going to cover every aspect of custom wiring coming up. I'm going to go through each aspect bit by bit. When it comes to heat shrinkless sleeving, you actually use heat shrink. And the heat shrink you use, it should be a thicker heat shrink. Usually the cheaper ones are the way to go. Now, the positioning of the sleeving is very important. It needs to be in between the two crimps on the pin. Each pin has two crimps. One crimps onto the insulation, one crimps onto the wire itself. So it needs to be in between those two. And you can see where I have the sleeving here. Now, you bring the heat shrink so that it lines up with the end of the sleeving, and then take it just past the end, maybe a couple of millimeters. And then you don't heat all of the heat shrink. Now, some people use lighters for this. It's really up to you. I'm using a small torch, which actually has a lighter inside of it that you can refill. So it's very handy. And the good thing about this is it spreads the heat out a little bit, more evenly. It's less heat. It's easier to control, and I recommend it for beginners. And actually, I recommend it anyway. I find it's really handy for getting into tight spots in builds if you need to sleeve later on. You can't do that with a lighter. So anyway, you can see what I'm doing here. I'm melting one end of the heat shrink, as I mentioned, and you really need to get stuck in and give it a lot of heat. The heat shrink needs to start melting. As you can see, I'm burning it. Don't take it too far, but always be constantly moving the heat source so that you don't burn it too much. But you really do need to heat it up, and make sure you only heat a 3mm strip on the end of the heat shrink. If you go too far back, you're going to end up seeing it later. And also, you won't be able to cut the heat shrink off very easily. So as you can see, I didn't go all the way back to the end of the heat shrink, so it was really easy to cut the heat shrink off. And now you can see what I'm left with is a melted, the sleeving is melted, and you can see it's melted because you can't see the individual strands anymore. And it's approximately a 3mm strip, and this is incredibly durable, because where it's melted between the two crimps is a thin, the thinnest part of the pin, so it has to pull back over one of the crimps. It's melted into the crimp, it's melted into the insulation. It's not going anywhere. This is very durable, and you should always test it. So hold on to the pin, try to pull the sleeving back to make sure that it's very firmly in position. I've now completed the core cables and I'm testing them. So this is always the first test I do. I'm using a power supply tester, which you can pick up from just about any computer store. They're cheap, and I find this is an effective, quick and easy way of testing your cables, because this will report back any problems with your cables, bad pinouts. It can even handle shorts. So it's a great initial test. I've now sleeved all of the fan wiring and also the pump wiring. I've also customized it to length. Now you can see that I've used heat shrink on these cables, and that's because there are some cables you have to use heat shrink on. Basically, wherever you can run the sleeving inside of the connector, you can do heat shrinkless sleeving. But where you can't, fan wiring for example, you have to use heat shrink. So what I do is I do heat shrinkless sleeving on all of the core cables, and on the rest of the cables I use heat shrink to match. So I'm really happy with the way I managed to get the fan wiring. It's all thanks to the splitter PCB. It's just such a clean way of doing things compared to splitter cables, which make an absolute mess. So I've run all of the fan wiring down the sides of the fans, and all of that is going to be out of sight with the side panels installed, including the splitter PCB. I have some of the stock power supply cables here, and what I'm doing is looking at the pinouts and copying them on my custom cables. You need to do this with all of the power supply cables. Obviously the pinouts are absolutely critical, and they're different with almost every single power supply. I've now installed the SATA data cables. As you can see, I've sleeved them in white. You can see that I've run the heat shrink up and over the connectors, and you should do this wherever you can. It looks a lot cleaner, it's also more durable. Now I have 3 SATA data cables because I'm still planning on installing a hard drive, although I'm not yet sure where I'm going to install it. I've now completed the SATA power cables for the SSDs and hard drive, and also a Molex cable which is going to power the fans, the pump and the lighting. So you can see this Molex cable has 2 connectors. The one on the end is going to plug into the splitter PCB, and this 90-degree Molex connector is for the pump. So this connector is going to be out of sight. It's going to be back close to the power supply. You can see I haven't sleeved this section, and that's something that you can often do. Where you have short lengths of wire, there's no need to sleeve it. It just makes more of a mess. For example, SATA cables for a hard drive cage where you have a whole bunch of SATA connectors close together, you don't sleeve in between on those short lengths. I decided to run the SATA power cables separately, so I have 3 separate cables. This is going to be the cleanest way to do things instead of stringing them all together. I've now completed, installed and managed almost all of the custom wiring. There's just one more thing I still need to do to complete the build, and that is install the wiring for the lighting. I've already installed the lighting, and what I've decided to go for is 2 Bitfinex Alchemy White 30cm LED strips. I've actually cut down the LED strips so that they would fit, and every time I cut an LED strip I always put something over the end, usually double-sided tape, just to stop any possible shorts. So I have 1 LED strip on either side of the build, and I was planning on using some LEDs in the graphics card water block, but I'm finding that most of the LEDs that are available fail very quickly, and I think it's more due to the way that they're wired up. And because I'm doing custom wiring, I'm running the LEDs off a 3-pin fan header a lot of the time, and a lot of the LEDs that I'm using are 5-volt LEDs, so it's something that I'm looking into. I'm going to get my hands on some 12-volt LEDs and come up with my own configurations for LEDs, do all of the soldering, the custom wiring from the ground up, because currently I'm still using XSPC and ModSmart LEDs and still using their wiring. So this is the wiring configuration for the lighting. I have here the Vandal switch all wired up, and this wire goes to the power source, which is going to be the extra 3-pin fan header that I have on the splitter PCB, and the other 2 wires go to the Bitfinex Alchemy LED strips, and you can see the custom connectors for the LED strips that I have here. Now I could have wired the LED strips straight into the this configuration, but I wanted it to be serviceable. So if the LED strips ever need to be replaced, you can just unplug them. That's always something you need to consider when doing custom wiring. It is cleaner a lot of the time to just wire everything, hardwire everything in. But you need to make sure also that everything is easily serviceable. So that's it. I'm going to install the wiring for the lighting and then the build will be complete. So the build is now complete and I'm now going to give you a brief look around at the finished custom wiring. Now I've talked a lot about a hard drive I was planning on installing. At this point I've decided against installing the hard drive and I'll talk about why coming up. So you can see the SATA power cables, I've curved them around in the same way on either side of the build so they're uniform. So there's now just two SATA data cables, which is a bit cleaner. You can just see the 24-pin cable there. That was actually really difficult to manage and get into position because it's a tight fit. You'll notice that I've used a number of ModSmart cable routing components around the build, including the ModSmart cable clips that I often use in my builds. So I've already covered what I've done with the fan wiring. You can now see that I've taken up the 5th 3-pin fan header on the splitter PCB with a wire for the lighting. Now you only have a small gap between the power supply and the front of the motherboard tray in the BitPhoenix Prodigy. So this makes cable management difficult. And if you're doing custom wiring, you need to make sure that your cables are incredibly high quality. I mean, you always do, but your cables are going to be under a lot of pressure at this point. You know, even with the shortest possible power supplies, which actually Silverstone has some excellent options. They have some, you know, reasonably high-end power supplies that are nice and short, so they're perfect for this case. You can see that I've used a lot of heat shrink on the back of this vandal switch. So this is the vandal switch for the lighting. And, you know, the wiring is messy on the back of a vandal switch. So there's not much you can do about it. But what I've done here, I have a single cable going through to the splitter PCB for power. And then I have two going to the LED strips. I have one on either side of the build. So I've run them up in the corner next to the power supply there. And one goes over the top of the power supply. And one goes to this side of the build. So now for a look around the other side of the build. You can see what I've done with the PCIe cables and with the 24-pin cable. And I had a lot of different cable routing options for the PCIe cables. I could have run them up behind the graphics card, up around the end of the graphics card, but I wanted to show off the custom cables as much as possible. So I wanted them out here in full view. And I also routed them this way because it almost mirrors the curve of the 24-pin cable, so I think it fits nicely. So you can see the 24-pin cable goes straight up between the back of the graphics card and the reservoir. You can see the SATA power cable here and also the cable that comes from the power button, which is the other vandal switch I have on this side of the build. So all of the cables are hidden for both of the vandal switches, which I'm really happy with. Now this cable here is for the LED strip on this side of the build, and I've actually run it between the motherboard tray and the power supply. There's about a 10mm gap, so this is excellent for cable management. By popular request, I'm now going to take you around the water cooling loop and cover all of the fittings that I've used. So starting at the bottom here, I've used a 5mm extension fitting, 90° single rotary, 90° dual rotary, two multi-link fittings, a 90° single, 5mm extension fitting. Then coming back out of the pump, I've used a 90° single rotary, another couple of multi-link fittings. I've then used this other type of 90° single rotary, another couple of multi-link fittings, 90° dual rotary, 15mm extension fitting, 90° dual, a 90° single, multi-link fittings in between obviously, another 90° single, multi-link fittings, 90° dual, another 90° dual, multi-link fittings, 90° single. Then coming around the other side, I have more multi-link fittings, a 90° dual rotary, 90° single rotary. Then I have the drainage system. So I've used a Q fitting here with a rotary fitting on two sides. On one side, I have the bits power tap connected to a mini D plug. On the other side, I just have a plug. Then going into the radiator, I have a 15mm extension fitting. So that's all of the fittings I've used in this build. I'm now going to give you a good look around at the finished product. Now, it's difficult to find a good position to install lighting in this build, and it's often the way because there is a lot of things to consider when installing lighting. You need to hide the light source. It needs to be shining on the components you want lit. you need to find somewhere it fits, where it's not up in a gap where the light can't radiate. So the only position I could really install the LED strips in this build was on the back panel. So the one on this side I've installed facing inwards, the one on the other side I've installed facing forwards so that it shines down the side of the graphics card water block. But actually in a build with a black and white color scheme, if you use white lighting, it's often not so critical where you install the lighting, because take a look at the coolant and also the white sleeved cables in this build. It looks like they're glowing, almost like a UV effect, like they have their own light source. And that's because these components are obviously picking up the light, they're reflecting the light. So it means that it doesn't really matter where you install the light, as long as some of it reaches the white components, it really shows up. Okay, the reason I haven't gone ahead and installed the hard drive. Now the last decision I made about the hard drive was to drop down to a 2.5-inch hard drive. Now right from the beginning with this build, I recommended external storage. There's so many different external storage options, because one of the main directives for this build was extremely clean aesthetics. So I knew with a build of this form factor, the only way to achieve that was to certainly cut out all non-critical components. I'm now going to start going through the test results, and while I'm covering the test results, I'm going to continue to give you a good look around the finished product. So I'm going to start with the temperature results. I've overclocked the CPU to 4.4 GHz 1.25 volts. I haven't overclocked any of the other components because it wasn't requested. Now I have to play it very safely with my overclocks in my client builds, because obviously my client builds need to run perfectly indefinitely. So I usually back off my overclocks a substantial amount just to be safe. But I had to back them off further than I normally would in this build, which I was actually expecting. Now my target overclock was 4.6 GHz 1.3 volts, but at this overclock the motherboard was getting too hot. The motherboard was actually going up over 65 degrees Celsius. The PCH was getting up over 70 degrees Celsius. Now this is to be expected with an ITX motherboard. The power delivery components can't handle extreme overclocks, and because the board is so small, the heat radiates and all of the components heat up. But I'm really looking forward to testing the Asus Maximus 6 Impact, putting it up against this board and seeing if these problems have been solved. I'll be testing the Maximus 6 Impact in the Client Build 11 build log. I'll put a link on the screen. Now at 4.4 GHz, 1.25 volts, the maximum motherboard temperature was 53 degrees Celsius. The maximum PCH temperature was 67 degrees, and those were the hottest temperatures during all of my testing. Now for the CPU temperature results. At stock clocks at idle 29 degrees Celsius, overclocked at idle 29 degrees Celsius. At stock clocks at load 55 degrees Celsius, overclocked at load 64.5 degrees Celsius, so it was 9.5 degrees hotter. The graphics card results, the GPU at idle 21.5 degrees Celsius, at load 37 degrees Celsius. Now I mathematically adjust my ambient temperature to 20 degrees Celsius for all of my testing. And my testing methodology: for the idle test, I cold boot the system and let it idle for 30 minutes. For the load test, I run the AIDA64 stability test for 30 minutes for the CPU, and the Unigen Heaven benchmark for the graphics card. Now moving on to the noise output results. Now all of the components in this system are rated at less than 20 decibels. And the noise output, my estimation would be that it is just above 20 decibels. I have the pump running on PWM by PWM control, and I'm using the CPU fan profiles in the BIOS to control the RPM. So I'm just going to give you a quick listen to the system, and this is with the pump at 100% RPM. Now moving on to the performance results. Now I ran some game tests for this system, and it's something I'm going to continue to do from now on. For Battlefield 4, I got an average frame rate of 59 FPS. For Crysis 3, I got an average frame rate of 46.2 FPS. My testing methodology, I used Fraps and ran a 60-second time trial. Now the rest of the performance results I have in screenshots. I have stock clocks results and overclocked results. I also have results in there for the RAID 0 SSD configuration. So the performance difference between the stock clocks results and overclocked results was about what I expected, considering I only overclocked the CPU and only took it to 4.4 gigahertz. It's not as if overclocking was critical for this build, but what really would have benefited this build would have been a motherboard water block, because it was the motherboard temperatures that prevented me from pushing the CPU overclock further, as I've mentioned. But even as it is, I could have pushed the CPU overclocks further. I could have also overclocked the graphics card and even the memory. This water cooling loop has so much headroom. Anyway, it's now time for me to conclude this review. I've really enjoyed building this system. I had a fair bit of freedom with the mods, and I always enjoy doing something with extremely clean aesthetics. I have so many more builds coming up. I'm currently working on 5 different systems, and I have 3 new build logs starting within the next few weeks. I also have builds lined up all through the beginning of next year, so I have a lot of exciting videos to come. That sums up this build log. Thanks for watching. Please subscribe, like, and favorite if you want to see more.